Hello, everyone. My name is Christian, and I attend St. Basil the Great College. I'm a grade 12 student currently taking the Calculus and Vectors Enriched course, and right now I'm going to solve a problem. So, let's read it. If vector A equals I plus j minus k, B equals 2I minus j plus 3k, and C equals 2I plus 13k, determine the magnitude of this expression. So at a glance, this problem does look daunting, but if you small chunk it, it really isn't that bad at all. So first, we're given three variables, A, B, and C, and we're going to have to identify what the variables are, the coordinates of the three variables. And how we do that is we look at what A equals, and A equals I plus j minus k. So I, j, and k are known vectors. They're known unit vectors with magnitudes of 1, and they have coordinates of 1 on their respective axes. So I has a magnitude of 1 on the x, j on the y, and k on the z axis. So to display that, vector I equals 1, 0, 0. So a magnitude of 1 on the x-axis, and this is x, y, z. Vector j has a magnitude of 1 on the y-axis, so 0, 1, 0. And k, magnitude of 1 on the z-axis, 0, 0, and then 1. So what we're going to do now is substitute these unit vectors into this equation to solve for A. So vector A equals I is 1, 0, 0, plus j is 0, 1, 0, minus k, so 0, 0, 1. Now to add coordinates in 3D, it's very simple. All you got to do is take the first number and add the x coordinate to all the other x coordinates. So x coordinate here is 1 plus 0 minus 0. So it's 1. Now add all the y coordinates. So 0 plus 1 minus 0 equals 1. 0 plus 0 minus 1, so it is negative 1. So vector A equals 1, 1, and negative 1. Now we're going to go over to B. So B equals 2j minus j plus 2I minus j plus 3k. So 2 times I, which is 1, 0, 0, minus j, and j equals 0, 1, 0, plus 3k. 3 times 0, 0, 1. So 2 times 1 is 2. 2 times, all you have to do is just simply expand it. So 2 times 1, 2 times 0. So when there's a coefficient in front, all you got to do is expand to get the coordinates. So 0 minus 0, 1, 0, plus 3 times 0, 0. 3 times 1 is 3. And again, just add the respective axis. So add all the x-axis, so 2 minus 0 plus 0 is 0, 2. 0 minus 1 plus 0 is negative 1. And 0 minus 0 plus 3 is 3. So that is the coordinates for the B, for the vector B. Now we're going to do vector C. So 2 times I is 2, 1, 0, 0, plus 13k. So 13, 0, 0, 1. So expand again to 0, 0, plus 0, 0, and 13. Now just add the respective axes, so 2, 0, and 13. Now we have vectors A, B, and C. So what we're going to do now is determine the magnitude of this expression. Now we have all the variables. What we could do is simply substitute, whenever we see a variable, substitute in the numbers and do it the extremely long way. Or we can make our lives easier and simplify this expression first and then substitute the variables at the end, which is what we're going to do. So we're going to simplify this expression first. So the magnitude of 2a plus b minus c. So all you got to do is expand like you did before over here. Just expand 2 times a plus 2b minus 2c. Leave that in brackets. Minus a plus 2b plus, expand the 3, so 3a minus 3b plus 3c. And now you add like terms. The like terms are the same vector, so add all vector a's, add all vector v's, etc. So 2a minus a plus 3a equals 4a, the magnitude of 4a. 2b minus 2b is 0, minus 3b is negative 3b. Negative 2c plus 3c equals c. So now we have a simplified version of this. That's all we did. We expanded and we collected like terms and we ended up with this expression. So now it makes our lives easier to simply just substitute a vector into this and solve. So 4 times the a vector, which is right here, 4 times this set of coordinates, minus 3 times the b set of coordinates, so this, 2, negative 1, and 3, plus c, which is this set of coordinates, 2, 0, 13. And now we're going to expand the 4 to this set of coordinates, so 4, 4, negative 4, minus, we're going to leave the minus and pretend it's not there, and we're just going to expand the 3. So 3 times 2 equals 6, 3 times negative 1 equals negative 3, and 3 times 3 equals 9. And we left the minus there, so we're just going to subtract that after. So 2, 0, and 13. And it's the magnitude of that. Oh, I gotta keep that And then, now all we do is simply add or subtract the respective axis. So we'll add, so we'll start with the x-axis. So 4 minus 6 plus 2 equals 4 minus 6 is negative 2 plus 2 equals 0. 4 minus negative 3, so 4 plus 3 equals 7, plus 0 equals 7. And then we do negative 4 minus 9, which is negative 13, plus 13 is 0. So now the magnitude of 0, 7, and 0 is simply 0. Just like the magnitude for I is, just like the magnitude for unit vectors is 1, like 1, 0, 0, it's the same thing as this. 0, 7, 0, the magnitude will be 0. The magnitude will be 7. And that's the vectors solved. Thank you for watching.
What does that even mean?